That's okay. Can everyone hear me okay? Yeah, that's all right. So just for my benefit, who wasn't in the presentation a couple of sessions ago on big data? I just want to see. All right, so we've got a couple. Okay, so I'll in that presentation we talked a lot about big data trends and what some of the customers are doing, and really, so for this presentation, what I want to do is show you a demonstration of what that looks like from the complete end-to-end. So everything from being able to connect to different data sources, including Hadoop, what Hadoop looks like, how you transform that data, move that data, analyze that data for BI, as well as analyze that data for analytics as well. So there will be a lot of demo involved, and yeah, I'm just going to give you a little bit of an introduction of what I'm doing and why I'm doing it first. So just a little bit about Actian. Went through this a little bit in the last presentation, but we're one of the largest database analytics specialist companies in the world. We have our global headquarters, our regional APAC headquarters here in Melbourne. In total, we don't just do big data analytics, but we have 10,000 customers worldwide. We have 250 people skilled in analytics. And we have the fastest and most scalable big data technologies that are out there in the market. And this is the complete end-to-end suite. And the purpose of today is for me to show you what that looks like and how it works. Don't just take my word for it. Robin Bloor, who presented earlier today, he certainly endorses us. He says that we're now very powerfully positioned in the big data market and analytics market because we have so many new innovative technologies in that space. Forrester says we're becoming a powerhouse to challenge the market or the traditional vendors. So, they're talking about the IBMs, the Oracles, the Exadatas, these types of guys. So it's generally who we replace because their systems are not up to scratch. In terms of our customers, we have some of the world's largest customers are built using our platforms. Hopefully you've all heard of Amazon Redshift. If you are getting started to build up a BI environment, it's a fantastic product and it's actually built on our system. So our MPP database, they white label, and it's actually a cut down version of that database. It doesn't include all of the advanced analytic functions that we have, and it doesn't include all of the advanced data movement tools that we have as well. And what we find is a lot of customers that start using Redshift will actually switch over to our system when it suddenly doesn't meet their needs because everything's the same. It's not just Amazon Redshift, Yahoo. Whenever you see an ad that comes through Yahoo, that is powered by our system on the back end. And look, we really do do a lot of business with the industry leaders in either the specific country or the specific verticals. So in retail, we talked about a few examples in the last presentation on Office Max. So reducing their market basket analysis down from 85 hours to just 75 seconds and removing all of the need to do all that manual work, which I hear mentioned a lot about. Sorry, I think I'm flicking this the sound in my hands. Anyway. So there's leading retailers in Australia such as Pacific Brands. There's online gaming companies who use us to be able to learn how people play their games to be able to upsell them for either coupons or the next game. There's online dating sites. There's a number of them, including Badoo, which is I think the largest in the world, and I think it's top 50 or top 60 most visited websites in the world. And again, that's a situation around advertising. So you might be talking to someone and you'll get ads that are contextualised to that conversation. There's the Department of Defence, and there's lots of leading organisations that are there on the list. So earlier today I showed you just a couple of slides, which I'm just going to recap. The first was that data-driven organisations are out-earning their counterparts in their industry. And it varies depending on the industry, but there's a lot of evidence that shows that the companies that are taking on this big data technology and are able to really extract the value are winning in the marketplace. And you think about all these tech companies, they're not 100-year-old companies. They started, 15, 10, 5 years ago and are taking on the giants because of how they've managed to do stuff. They didn't need that huge investment. They just chose the right technology that their competitors weren't using. And then I showed you this chart, which is really the story that I'm going to take you on today. So in order to become an analytics-driven company, you need to go on a journey. You can't just suddenly all of a sudden wake up and do everything through analytics. It starts with asking questions such as what happened or what is happening now, which is really that static component at the bottom. Then it is going to real time, looking at the data as it's happening, getting alerts, being driven from that way. From there you progress on terms of predictive analytics. So this is using all the historical data to better predict what's going to happen next. And from there you can start to build your whole business systems around that. And really the main thing that we're going to show you today is I want to take you on this journey from static to reactive to proactive to dynamic and show you through the demonstration really what it looks like. In terms of the Actian Analytic platform, look, we're all about making things simpler through extreme performance. We believe that a lot of the stuff that people are doing on the database side is tuning and there are optimizations, but you're doing that because the core database was too slow in the first place. One of our flagship products is a product called Actian Vector. It used to be known as VectorWise, and that was based on a project which looked at the database is actually 100 times slower. Relational database 100 times slower than if you do a C query. So why is it that slow? What are all the bottlenecks? How do you remove all those bottlenecks so that you can get that optimal performance? And so really we've tried to work that in from the entire platform, from being able to connect, from the transformational side of it. Everything we do has parallelism built into it. And when you remove each of those bottlenecks, if you can get each of those specific steps down to a second or a microsecond, you can actually turn advanced analytics that might have taken weeks down to seconds on as much volume as you want. You can just throw another machine at it. So I did get a few questions afterwards, so I've just put this in there, but the Actian's platform is really built from the ground up to do this entire analytic process. So we're not using technology design in the 80s or 90s or for gigabytes, as Robin Bloor was saying before. It's really designed for terabytes and above. And as part of that, data capture is a huge component. If you're collecting terabytes of data, you probably want to use Hadoop. You could use Oracle or some of these other systems, but the amount that you pay for Hadoop and the performance and the ease of use, you'd just be crazy, in my opinion. I think for big data and big data types, so machine-generated data and unstructured data, voice data, all these things, it really is a superior tool. And Facebook, Amazon, Yahoo, these guys spawned everything. They weren't using the traditional systems. They knew it couldn't do what they wanted to do. So that's why they've developed these products which are now going mainstream. And it's surprisingly how fast this is now going mainstream, from the small shops to the banks and the retailers, all the way up to the big guys as well. So because this is actually a big part of our component, if you don't have big data, you probably don't need what we do. Hadoop does sort of form a bit of a foundation. And we see ourselves as a bit of a wrapper around Hadoop. There's a few different flavours of Hadoop that you see there, Mapper, Cloudera, Hortonworks. They're like the Red Hat or CentOS or whatever, the different flavours of Hadoop. So our abilities start with being able to connect to any data types. So Hadoop, it could be your enterprise data warehouse, which might be SQL Server or Oracle or Exadata or Teradata, Greenplum, any of these tools. We can connect to all of them. It might be data that's in the cloud, or it might be spreadsheets. This application data, we have built in the ability to be able to connect to these different data sources and analyse that data. And in many cases, if you'd like to blend that data with other data sources, that's something that our customers ask all the time. In addition to that, our platform comes with a suite of, it's about 600 plus advanced analytic functions. So these go beyond the standard SQL stuff. So might be machine learning algorithms, those types of things. So that comes complete with our full suite. And we've tried to build this system for the next generation of users who don't want to do all coding. They just want to drag and drop and use the operators as they need. And this is what I want to show you today. In terms of building these huge systems, you actually need a lot of flexibility. It's not a one-size-fits-all thing. And in some cases, you actually want to do your data exploration directly on Hadoop. And we give you the ability to do that. In other cases, if you're doing traditional BI, so you want to just slice and dice the data, Hadoop's probably not the best place to do that. So we give you the ability to move in parallel that data into a highly structured relational system, which is more optimized for that. We have the high-performance SQL, and yeah, basically it's all about speed at the end of the day. A lot of the new things that are coming through are not so new, but we can actually do R in database. So I'm not sure if you know much about R. It's you use it to build models, but it is a single-threaded machine, which means that you have to wait for each process to go. So if you can do all of that in parallel, and granted there are a few things that you can't do in parallel, but if you can do most of it in parallel, you can actually get down that whole process down to a tiny amount. So Robin Bloor mentioned before as well the ability to scale up as well as scale out, and that's exactly what we do. So this is a little bit cut off at the end, but there are some TPCH benchmarks which we participate in, and you can see there, so this is basically a benchmark between the hardware and the software vendors. When you submit a benchmark, you get your machine working as fast as is possible to get going. And the numbers are sort of cut off there, but we've got the largest marks by this. We've smashed all of the benchmarks by the largest margins ever performed, and we've done that on less hardware than the previous benchmarks were. And our competitors have actually resubmitted benchmarks years later that are still half the performance that we've done. And if you look at the actual cost of that, so this is a 1 terabyte benchmark, we're running on $57,000 worth of hardware. Microsoft, $406,000 worth of hardware for less than half the speed. And Oracle, $2.4 million worth of hardware for less than half the speed. So this is the type of scale up that we talk about. And then on the scale out side, and this is a comparison to really an MPP database, but the more complex the queries get, the faster we actually get in comparison. And there really is a lot of technology. There's a lot of different reasons why we get that performance. I'm happy to talk to you about it, but I try to avoid it in these conversations. In terms of the advanced analytic functions, there's a whole heap. We can do that directly on Hadoop, or we can do it in database. And then also when it comes to doing analytics directly on Hadoop, there's really two sides of this. One is data processing, and a lot of people do their data processing on Hadoop through MapReduce or PIG. And I guess MapReduce was designed for redundancy. Hadoop is amazing for redundancy. These social network sites don't go down. But as a result, it writes everything back to disk. And because of the way that we've designed our flows, of how the data flows, we're actually able to process the data 5 to 10 times faster than MapReduce, using the same hardware, doing the same jobs. We're doing it all in memory, and we're doing it by thread, by core. We're splitting up the work as much as possible. And then in addition to that, our tools be able to build those workflows come down. You don't have to write programs anymore, so they can come down from days or in some cases weeks to literally 10 minutes, half an hour or an hour to be able to build these jobs. In terms of doing analytics directly on Hadoop, we also, this is something that's very new that's coming out. We have the ability to do that too. This might be over a few people's heads, but there is a product out there called Impala, which is basically SQL on Hadoop. We have our own version, and you can see that we're on average, it's cut out, but we're on average between 10 to 15 times faster than that as well. So the complete end-to-end suite, we try to do everything as fast as possible. So this brings us on to our case study. So today's case study is actually using real data from the telco industry. Can explain to you another time how we have that data. They did give it to us in exchange for a few things. But I'm going to show you a few different examples, including how our platform was able to improve their internal network analysis, so how calls were routed, as well as being able to predict customer churn, which is a really, really important metric in the telco industry. So we're going to start this demonstration by analysing the data directly, or looking at the data. So I'm going to show you HDFS, or the Hadoop distributed file system. I'm going to take that data, at some point I'm going to blend that data with other data sources. And what we're looking at is what's known as, they're de-identified, but they're called detailed records. So a call detailed record, every time you make a call, a log happens. There's lots and lots of different columns that are in that log, including the origin number, the destination number, the time, as well as how that call was routed throughout the network. So if you try to go through, so let's say I'm calling Indonesia, I might go through Vodafone, which goes through Telstra, which goes through someone in Indonesia, which then goes through another company. So calls actually need to get routed through the system, and that's why if I'm calling somebody down the street, the phone might ring straight away. If I'm calling someone overseas, it might take a lot longer for that call to connect. So there's lots of different metrics in there. Excuse me. So we're going to take you through this solution from the data in Hadoop and show you a number of different ways we can create transformational value from this. And if anyone has seen, we actually did a webinar on part of this earlier in the year with Ivan. Ivan actually helped us develop some of this stuff, but we're going to do a little bit more than that today. So if you have seen that webinar, apologise, but there is a lot more to it afterwards. We're going to go into the advanced analytics stuff. So this example really starts off like any other big data story. So the business was collecting enormous amounts of data. The data was not always in the format that they needed that data. They knew the data had value, but they were really struggling to be able to extract the value from the data. So specifically what they wanted was just faster time to decisions. They were tired of waiting hours or days for a simple answer to a business question. And in addition, they were unable to answer many of their business questions because the data that they had in these call detail records lacked a lot of granularity. So I'll give you two examples of that, which you'll see in the data flow that we'll bring up. But specifically, they were unable to analyse their calls at the area code level because the data actually didn't have the area code level. They had a whole heap of other information, such as the telephone number, which you could extract the area code out of, but it didn't actually have the area code, so they couldn't just ask that question. In addition, I mentioned before that it included different columns of how the data, of how the calls were routed throughout that path. And they were all on separate columns. So if you wanted to drill down into a specific call and look at how that call was routed, you actually need to be able to pivot those columns into rows to be able to get that ability to drill down. But it wasn't in that ability. It was just a log inside, basically inside of a text file. So they didn't have the ability to be able to get that drill down. This was, I guess, quite important to them because what they wanted to do, they knew that a lot of their calls were failing to connect, but they didn't know where the calls were failing to connect or which routing vendors were failing to connect. All they knew is that a heck of a lot of them were failing on the routing path to connect. So proactive analysis was very important. They wanted to be able to answer real business questions, but they wanted to deal with that as it was happening, not weeks down the path. And they didn't want to use something which wasn't built for scalability. So, they didn't want to come 3 to 5 years later where suddenly they didn't have a new system because it had reached its max. They were looking for something that was able to grow with their business. From an IT perspective, so from IT, they were getting swamped by data. So each switch was producing over 100 megabytes of data per minute during the peak times, and that's hundreds of thousands of records per drop. Wisely, they'd chosen to store this type of data inside of HDFS because it was simply too much data and too expensive to store within a relational system. Their analysts or their users, they were domain expertise, however, you would not class them as data scientists. So they were finding it very hard to be able to analyse the data because it first needed to be distilled and then enriched in order to be able to gain any insight from it. So what we're about to show you is a demonstration from the data stored in Hadoop. So now's probably a good time to ask, just so I can understand the audience a little bit. Is anyone here using Hadoop at the moment or thinking of using it in the next couple of years? So, a couple? Okay. So, it is a growing area. I was really surprised by these statistics at first, but the more people that we were speaking to at the moment really are using this. And according to a recent TDWI study, 53% of enterprises reported that they are either using or expect to have Hadoop in production in the next 3 years. So it's definitely not just the domain of the internet giants. But this same study also found that 71% thought that big data analytics would be beneficial, the biggest benefit really of that Hadoop implementation. I guess there's a key point here is that a lot of people think that when they collect all this data they can then analyse it, but Hadoop was never really designed for analytics. It is absolutely superior to relational databases for storing large, scalable volumes of data. But if you want to be able to quickly slice and dice that data, Hadoop has a lot of glaring well-known weaknesses, starting with MapReduce, the lack of all the SQL functions. So most organisations actually find it painfully hard and slow to analyse their data in Hadoop. There are a few reasons for this. The reason why it's hard is it is just a file system. I'll show it to you in a minute, but it's just a file system. You browse a file system, the data's in folders, and that's all it is. So for log files and structured data, awesome. But the next is that analytical queries that you run on Hadoop, they might resemble SQL, but they're not standard SQL. And analytic databases have been around for a while and they're highly optimised. And these types of SQL-like queries that you do, whoa. Okay, I've just been kicked out of my VPN, so I'm going to run that again. So these types of queries that you do, they're not optimised, they're not going to utilise the hardware that's available as well as other systems. And then once you have all that, you really do need that data scientist to be able to do anything with it, write the MapReduce jobs. And then when they do write those MapReduce programs, that query isn't as fast as it could be because it's all running on disk and it's not optimised. So now I just got kicked out of my VPN. So I'll just show it to you here. But this is Hadoop here. Hopefully this loads up. But essentially what you see here is we have a Hadoop cluster, and this is actually a 5-node Hadoop. Oh, great. This is a 5-node Hadoop cluster. We've got 106 terabytes in this cluster. We're using 66 terabytes. And if you look through it, it's really, browse the file system. That's what it is. It is a file system. Hopefully this works, otherwise this demo is in a bit of trouble. Do we have... Sorry guys, it's embarrassing. I'm going to not use, this is what happens when you do a demo using Wi-Fi. Okay, let's see if I can get this going.
This has never happened to me.
You should never trust technology.
Okay, I'm going to talk you through it. This will work in a minute. I have had this happen once before actually. So what happens if I browse this file system, and this is probably not going to work this time, but what you'll see is basically a list of file systems, and what I was going to do is I would go into the specific demonstration that I'm going to show you, and when this comes up in a minute, It will work. What you're going to see is the telco provider, they're collecting these log files every minute. The files are about 100 megabytes each, and that data gets dropped into a staging environment. We need to process that data and add meaning to that data. So as we do that, it goes through another folder as we're doing that, and finally it gets dumped into a run folder for us to use later on. So essentially what I'm going to do, this may or may not work, I'm going to then open up a Hadoop, one of these CDR log files, and with that, what you're going to basically see is there is just a whole heap of garbage that's in there. There's heaps and heaps of semicolons. Hey, Ryan, you got any suggestions here?
No.
Okay, I'm going to try it one more time.